I get asked a lot, what is going to come up on GCSE AQA Physics Paper 1? Now, we know there's going to be maths, there's going to be graphs. Today, we're going to focus on the content. Now, I'm not going to give you a prediction on what I think will happen, but I'm going to talk you through what regularly comes up, in particular, extended writing answers. So 6 markers, 3 and 4 markers, what kind of things could you be asked about? So we're going to look at a question from all the various years of AQA Physics GCSE, topics it's from, how you can answer them, and what the perfect answer, i.e. the mark scheme, would look like. So let's dive in. Having good exam technique is absolutely essential if you're going to answer 6 markers and 3 or 4 markers perfectly. So what you need to do first, and we're going to practice here, is reading the question extra carefully and underlining any keywords and also command words, like what is the question asking you to do. You're going to plan out your answer in brief, especially for those longer 6-mark answers, just like a couple of kind of notes on the side of the page, just so you don't forget anything. And also using bullet points to structure your answer. Some people don't know you can do this directly from AQA. They've released a document recently about misconceptions, saying you can answer by writing in paragraphs if you want, but also by using bullet points. Now, I've spoken to a lot of AQA markers. I'm an AQA marker of A-level myself. They say they prefer bullet points. So top tip, as long as you're writing in full sentences, bullet pointing your answer, easier to mark and easier to remember what's going on. So all these questions are things that have come up relatively frequently in Paper 1 GCSE AQA. There's also required practicals. Now, for those, please look at my required practical videos. We're not going to go through those today. This is just kind of the content of each one. So the first question we're going to look at is to do with atomic models. So this question says, explain what led to the plum-pudding model of the atom being replaced by the nuclear model of the atom. So we've got 2 things to talk about, and there's also an explain. So we've got to talk about why one thing was replaced by the other. So this is in the atomic models, or sometimes in the radioactivity topic. And your brain should be thinking, bear in mind this is on GCSE chemistry as well, about the Rutherford scattering experiment. So for 5 to 6 marks in this question, we need to, it says, demonstrate deep knowledge. You need to be able to talk about those 2 models and explain properly the evidence that enabled the nuclear model to displace the plum-pudding model. Examiners love asking about this stuff. So the scattering experiment, just a quick recap of what happens. This is when alpha particles were fired at gold atoms in a thin gold foil. Now, some of them deflected at angles, some of them deflected backwards, some of them deflected at small angles. Most of them went through. This was unusual. Okay. Now, to be able to get your marks in this question, we're going to talk about those 2 models, then we're going to talk about why this experiment helped find out the nuclear model was the correct, or the most accurate model of the atom. So you get marks in this question. This is the exact mark scheme for talking about the alpha particle, or the Rutherford scattering experiment. And we just mentioned these alpha particles are directed at gold foil. Now, the evidence we have is that most of them pass straight through, and this is where the explain comes in. So you see in brackets, obviously don't put in brackets in your answer. We say so therefore the atom is empty space. The evidence for that is that most of them pass straight through. The fact that some of them deflect, not reflect, but deflect through large angles, like these ones here, shows that the mass is concentrated at the center and is also positively charged. The repulsion between the 2 positives, so the positive alpha and the positive nucleus, means that it's deflected, or it experiences a force and repels away. Now, we haven't talked about plum-pudding model yet, so somewhere in your answer, this is the probably most minor bit of the question, you'll want to mention the plum-pudding model is the model that has mass spread throughout the atom and has a charge spread throughout the atom as well. So it's got the one that's got the little negative electrons spread throughout, positive charge in the rest of the atom. And that will be your 6 marks. Some of these 6 marks, you don't need to write an essay, you don't need to write down all those points, but you need to make sure you mention plum-pudding model, the nuclear model, and the evidence, so the alpha scattering experiment, and link it clearly to those models. Next question we're going to look at is one about radiation, or radioactivity, and it says, explain how the properties of alpha, beta and gamma radiation affect the level of hazard at different distances. So there's quite a lot to unpack here. We've got to talk about alpha, beta and gamma, their properties, i.e. what they are, and their hazard. So hazard meaning essentially what danger do they have at different distances. So let's have a look at what we could talk about here. Now, you do get lots of marks here for listing just the properties of each of them. So if you revise properly, you should know that alpha is the least penetrating, i.e. it gets absorbed easily by materials, but it's also the most ionizing. Well, you should also know it has the least range in air, which is due to those the fact it's ionizing. Next, let's talk about beta. So beta is the second most penetrating and moderately ionizing and the second longest range. And then we've got gamma, the last one, which is the most penetrating, but it's the least ionizing, which means it has the greatest range in air because it doesn't ionize many air molecules as it goes through. So these are the properties. Now let's link them to the hazard. Now this is one of those questions, a bit of an unusual one. It doesn't ask you to come to a conclusion, but you could talk about any of them being the most hazardous depending on which evidence you choose. So for example, if you wanted to choose alpha as the most hazardous, you'd say, well, it's the most ionizing, so therefore could do damage in your body, cause cancer, mutate DNA in cells, etc. You could talk about gamma being the most dangerous or having the highest hazard because it's the most penetrating, so you could say it gets through lots of different materials. So what we'd say is you'd say, okay, at different distances, you'd say short range, alpha must be the most dangerous because it's ionizing. If you're mid-range, so let's say a meter or something, beta will be most dangerous because alpha won't get through to you there, beta will, and it's moderately ionizing still. But at long range, gamma is the most dangerous. Okay, because even though it's not very ionizing, it's the only one out of the three that will be able to go more than a few meters with a lot of it not absorbed. Okay, next question we're going to go to now is all about states of matter. So this question is about solids and gases. It gives you some information in the box. It says that explain, essentially, use your knowledge of kinetic theory, that means particles, to explain the information given in the box. The box says that solids have a fixed shape and they're difficult to compress, whereas gases will spread and fill the entire container. So he says we need to consider these 3 bullet points. Now, this is so important with states of matter questions, especially if it's a 6 marker. You need to underline what are they asking you to say. So here they're asking you to talk about the spacing, the movement, and the forces between them. They're not asking you to talk about arrangement, for example, so you don't need to worry about that. And does it talk about liquids here? No, it doesn't. So there'd be no marks at all if you talk about liquid at all in this answer. It's only asking you to explain the box, which is solids and gases. So let's have a look at what different things you could get marks for here. Now we should know the spacing should be the easy part of this this answer really, because between the particles we should know that particles in solids are close together and that there's no room for particles to move closer. Now this question is about those properties, so it says they are difficult to compress. So the idea is that the particles are close together, as you can see from the diagram, so that they can't be compressed. The movement of the particles in a solid, you can talk about them vibrating about a fixed point, so essentially vibrating but not having any overall movement left or right or up or down. And the last one you can talk about is their forces of attraction. So they have strong forces of attraction, and you could say they become repulsive if the particles get closer. You wouldn't necessarily need to mention that, I don't think, to get 6 out of 6 here. But the idea is you've got to then use the idea of forces of attraction to explain, well, why is it that they have a fixed shape? So the particles are held together or have strong forces, so therefore the shape is fixed. So link those 2 ideas together. Now for a gas, it's the opposite basically. Gases and particles are far apart, so there's a big space between particles, so they're easy to compress. Again, just because these things are in brackets, you want to write them down because they link the ideas together really well. The movement, they move randomly. You could say a range of speed, overall quicker than liquids, for example. And lastly, the forces between them are negligible or none. They are not really connected together, they don't have bonds or anything like that between the molecules, so there's no forces of attraction, and that helps explain why the gas particle will spread and fill the entire container. So make sure you're linking those properties to what it asks you to explain here, and you can do it in bullet points, like I said earlier in the video, to help keep track of what you're talking about, because there's 3 different things you need to talk about for solids and gases. Okay, next one, we've got another states of matter question. This one's talking about, it's only a 4 marker this time, it's talking about only one thing. It says describe how the arrangement of sodium atoms changes as this sodium changes from a solid to a liquid to a gas. So this time we are talking about liquids, so solid to liquid to gas. We're just talking about arrangement, so we're not talking about speed, we're not talking about spacing or anything like that. So the mark scheme just purely talks about arrangement, so we're just going to talk about arrangement. Notice how closely matched this is to the previous mark scheme in terms of the particles, how they are. But this is, when we talk about arrangement, you've got to talk about patterns basically, or regular arrangements. So it says atoms are closely packed, they're in a regular arrangement. You could say a regular pattern there. You can say rows and columns, but a regular arrangement is much better. And the atoms vibrate about a fixed position. In a liquid, just to compare, same 3 bullet points, but slightly different because it's a liquid. They are close together, so maybe you could say not as close as a solid. There's no regular pattern, no regular arrangement, and they can move past each other. And lastly, for a gas, atoms are very well separated or are not work close together at all or have high separation. They're not in a regular arrangement and they move randomly at generally high speeds. And that's basically it. That's all you need to say for that question. Next one, we're going to dive into the electricity topic. We're going to talk about the national grid. So this question asks us to explain the main features of the national grid. So national grid is all to do with mains electricity. How does electricity get to our homes? And it looks something like this. This is from another question from another exam paper. We've got a power station, we've got step-up transformer, we've got transmission cables, step-down transformer, then the electricity gets into your home. So we've got three things to talk about really. The step-up transformer, step-down transformer, and in between the transmission cables. So let's do a brain dump then about step-up transformers. Well, what are they there for? We should know the step-up transformer increases the potential difference or the voltage. It does that so that it decreases the current. Now, as the current decreases, that reduces the rate of flow of electrons, which reduces the heating inside the cables. Now, that's a good thing because it means there's been no heat dissipated or wasted from the cables, meaning the transfer is more efficient, meaning there's less wasted energy. Now, on the cables themselves, you see there's a bit repeated here. You could talk about them having less heating effect, reducing wasted energy, and that'll be because the transmission cables, we try and make them out of something like copper or something similar that has a low resistance, because resistance also causes this heating and wasted energy. Step-down transformer should be the one that's easiest to remember. That decreases the potential difference and vice versa, increases the current to a safe level that is suitable for most domestic appliances. Now, I do need to mention all these bullet points. Probably not. Like, for example, the step-down transformer, normally it's about the PD being a safe level, so you might not need to mention about the current. But hey, this is the mark scheme, so we're going to use it to our best of our ability. Okay, next question. We're going to talk about, go back to a question about pressure. Now, pressure is one of those things, from my experience, people don't revise that well, but it comes up a lot, okay, in paper 1. So it talks about this question. The air pressure in a car tyre changes if the temperature in the air of the tyre increases. Explain why. Now, first of all, it doesn't tell us how it changes. Does it change increasing or does it decrease? Let's figure it out. So this question is all about states of matter. So we're talking about gases, so not solids and liquids here. I've got a handy gift to talk about gas particles and how they behave when they reach the wall of a container. So imagine this is a tyre. I know it's square, it's not circular. But as the particles hit the wall, they bounce off. Now, if that happens thousands and millions and billions of times, there will be a force exerted on the container. That's essential to answering this question. So we're going to do it bullet points. So the first thing is that this should be the easy one. With higher temperature, air particles have a greater kinetic energy or mean kinetic energy. You could say a greater speed, but hey, Mark seems to say kinetic energy. Let's say kinetic energy. Now that means that they're going to have more collisions with the wall or the tyre wall per second. So you notice the particles that are travelling faster here will bump into the wall more than those that are travelling slower. So more collisions, and per second, that is absolutely essential to write down as well, because not just more collisions, we've got to have indication of how long it takes those collisions to happen. In addition to that, they're travelling faster. Just like if you throw a ball faster, it will exert a greater force on the wall or whatever you're throwing it at. There's going to be a greater force in each collision. And then lastly, that means then there's a greater force per, you could say, square meter or unit area, which is what pressure is. So pressure is force per square meter per unit area. So therefore, there's a greater force. Okay, this comes up a lot. Combined science, separate science. Make sure you know a good 3 or 4 mark answer for talking about pressure in gases. Okay, we're going back to electricity now. We're not going to talk about mains electricity anymore. This is talking about essentially sparks, or this question could be about any electrical hazard, like why does someone get a shock? And the mark scheme is the same for all of them. So let's have a look what it's about. So it's an explain question. Explain why a spark jumps between a negatively charged rod and what's called an earthed conductor. Now, the earthed conductor just means something that's stuck into the ground to carry away the charge. But the key thing here is that if it talks about spark or if it talks about electric shock, electrocution, anything like that, it's the same mark scheme. Okay, so what we say is that for that to happen, there has to be a large potential difference between two objects. Okay, for any spark, which is a flow of electrons to flow, there has to be a large potential difference. Now, when that happens, the electrons or the negative charges will move. Now, another way of saying that is there's a current in the air in this example, but you could say the electrons move, and you've got to say where did they go from and where did they go to. So in this instance, they go from the rod to the conductor, so essentially to the ground. However, this question could be about lightning. So let's take a lightning example. There's a potential difference between the cloud and the ground. So therefore, the electrons move through the air. That's what the lightning is, from where they started, the cloud, to the conductor. If it's an electric shock, it will go from whichever metal appliance to the ground through a person. So it's always about the potential difference being large enough between two objects so that electrons flow. Really common question again, that one. Right, we've got one about energy transfers here. Here's a question about energy transfers, which is something that students might think is fairly straightforward, but you've got to be really specific with your language here. So here's the question. We've got someone on a trampoline. It shows they jump from low to high, and it tells you where they got stretched springs. It says describe, so not explain, describe the changes to these stores of energy in the child, the spring, and the surroundings. Now, when I've marked this question before, a lot of people talk about the child, not many people talk about the springs or the surroundings. So this is why we do bullet points for our answer, to make sure we keep track of what we have got to say. So the mark scheme for this one, let's talk about the child first of all, between A and B, so no other time. So A, they're up high, B, they're up low, they're down low, sorry. So for the child, the first thing is, when they're up high versus when they're down low, they are losing, or they have decreased gravitational potential energy. Now, when that happens, that reason that happens is because they're transferring gravitational potential energy to kinetic. When they're at the bottom of the trampoline, they're not moving anymore, so therefore the kinetic energy is zero. Okay, so that's a mark you've got to say in this question. It's not just transfers to kinetic energy, it means the kinetic energy basically goes to zero. Now let's talk about the springs. Springs will store elastic potential energy. So you'd say in a spring, the elastic potential energy increases. And then in the surroundings is always to do with thermal or heat. Okay, so you'd say the thermal store of the energy, or surroundings, sorry, increases. You could say energy is dissipated. Notice you can't say it gets hot. Okay, you've got to say thermal store increases, which is happening only in the surroundings as heat is dissipated. Okay, doesn't get any marks for sound here. It just talks about energy stores. So energy stores are these things here, not energy transfers. Okay, last two questions we're going to look at are separate physics only if you're doing AQA. So this one's here is about static electricity, a really common question to come up, could come up in a few different forms, anything about someone getting a mini electric shock or something like that. I guess to distinguish from the last question I looked at earlier, with the electric shock we're talking about here, it's got to be like a spark or like a severe electric shock happening with a fault or something like that, whereas with this static electricity, it's always due to something rubbing on something else. So this question says, explain how rubbing an acetate, so a type of plastic, rod with a cloth causes both of them to become charged. 4 marks. So what's happening is that if you have a look at the GIF here, when you rub the rod on the cloth, essentially it picks up these little red, in this diagram, these red electrons, causing the rod to have a negative charge and the cloth to have a positive charge, because there's not many electrons left. Okay, so how would you phrase that in a mark scheme? It would look like this. We'd say there's friction between whatever two objects are, the cloth and the rod. That causes electrons to move. Okay, you might want to say they are negative electrons, just to make sure you get your mark here. Now, you've got to say where they move from. So in the diagram, it's kind of clear they go from the rod to the cloth. Okay, so slightly different to my GIF, but it could be the other way around. You've just got to keep an eye on what the question is asking you to do. And then you'd say, to finish off, you say the charge on the cloth. So what have we got on the cloth? We've got a few more electrons here, is now negative, whereas the rod has lost electrons. It's got now an overall positive charge. Okay, so that's how you get your 4 marks in that question. Last one is about nuclear fission, so make sure you learn that process properly. It didn't come up in 2023, so I'll be very surprised if it didn't come up in some form in 2024 paper. The question says, nuclear fission releases energy. Describe the process of nuclear fission inside a nuclear reactor. So I've got a GIF here to describe what happens. So a neutron gets absorbed by uranium. Uranium splits, the nucleus of uranium splits and releases more neutrons. Those neutrons, I've got a diagram down here. You could be asked to draw a diagram about it. Those neutrons will go, just be released from the atom, and the nucleus has split into 2. Okay, now those 3 neutrons can go on to cause more fission. We'll talk about that in a second. So how we explain it in a really good 4-mark answer is that a neutron gets absorbed by uranium nucleus, and the nucleus splits into 2. It's always 2. Then you have some neutrons released. You could say 3, it can be 2 or 4. Any of those is fine. You could just say neutrons are released. And here's the bit people will miss out. There's energy released in the form of gamma rays. Okay, gamma rays, EM radiation, high energy. That's how energy is released from a nuclear fission reaction. Now, it doesn't talk about chain reaction in this question, so you don't need to talk about it, but if you were asked to talk about it, then you'd make sure you'd say those neutrons go on to cause further fission with other uranium nuclei, and the reaction continues several times. So just to sum up, here are my tips from earlier. Those are my kind of top tips for what regularly comes up in exam questions. So I would definitely make sure you learn them as best you can.